Hey kiddos, this is Mr. Pickett. I just wanted to let you guys know that I'm going to be gone Monday, Tuesday, and Wednesday of this next week. We're going to be absolutely fine with that, but I want to kind of give you a schedule on what we should be doing and what we should be accomplishing. Number one, on Monday, it's my hope that what we're going to be getting through is all of Learning Cycle 2. Those are all the labs dealing with the lights. Your application lab is having you guys. I gotta remember here, geez. Drawing a blank, I'll keep going on here. But the application lab should be the last thing that we're gonna hit up. And you guys are gonna be measuring the efficiency, of two different light bulbs. One light bulb being a CFL bulb, that's the bulbs that have kind of the twisty curly cues. And then the other one's the incandescent bulb. That's the normal light bulb that you think about that looks like this. And it's got some sort of a filament in the center of it. Okay, so that's the idea, is that we should be getting that completed. And please lean on some of your other groups that have done it a little bit. You're going to be making sure that you know the wattage of the light bulbs, and I'll have different examples here for you. On Tuesday, or on Monday if you get to it, we should start attacking Learning Cycle 3. And Learning Cycle 3 is dealing with wavelength, frequency, and the speed of sound waves. And we're going to be measuring some properties about sound. The first couple labs are really cool. I mean, the first lab, you're going to be taking slinkies, and you're going to be stretching them, and you're going to be trying to find the velocity of that slinky. Remember, velocity of really any object is calculated by taking velocity equals distance divided by time, making sure your distance is in meters and your time is in seconds. We should be pretty clear on that. Make sure that we're appropriate with the slinkies. Those things can easily be stretched and broken. Make sure that we're also not disrupting other classes. Sometimes we're going to take some of those slinkies out in the hallway. Just be safe. I know that seems really silly to ask, but please be safe with the slinkies as we're using them. Once we get through that, there's a concept development lab that has you guys maybe doing something with ripple tank and water tank. We're not doing that one. There's another one that you guys are going to be doing, and it's going to be dealing with a microphone. And we can get our microphones from, I guess, this drawer, and I'll show you where that's at. Follow me. All right, so this is my whiteboard. I'm going to walk over here, flag, all this good stuff. Okay. Going to keep walking over. Not this one, but this one right here. Here's our microphone, and I'll show you guys how to use that in a second. Okay. I haven't used this webcam program before, so hopefully it'll work out for us. All right. Yep, look okay. So when you're using your microphone on the Concept Development Lab, what it does is it actually measures differences in air pressure. And the directions in the book have you guys trigger to start that microphone, meaning that if you clap, which is one of the things it's going to ask you to do, it's actually going to basically say collect to the program, and then you clap again, it's actually going to read that and give you a spike. Well, the Logger Light program that we're using is not trigger based, which is what that's called. And so what you're going to have to do is you're going to have to hit Control D, and you're going to change the settings, add a little bit more time in there, so that way you can get 2 claps. We're basically going to measure how fast you can clap things together, but that's how you use the microphone. And eventually in the application lab, what you're going to be doing is you're going to be using a kind of a weird setup, but we're going to be able to make it work pretty easily. You're going to be using PVC pipe, which I'll have out for you, and you're going to be using a big graduated cylinder, so that way you can actually have a tube that you can constantly change the height of. So you're going to fill that graduated cylinder up with water, and that's going to kind of act as your bottom of your PVC pipe. And as you move the PVC pipe up and down in there, you're going to be able to change the bottom, or really change the length of the PVC pipe. And you're going to be using some tuning forks in conjunction with that. I'll share out Learning Cycle 4 once we get to it, but everything should be ready to go. If you have any questions or you get stuck in any way, shape, or form, please contact me, and I'll help you guys out as best as I can. Have a great rest of your Sunday.